Electrical Energy Measurement Part 4, Electrodynamic Wattmeter, Principle and Construction. 1. Why not just use an ammeter and voltmeter? We learned that in AC circuits, simply multiplying voltage, V, and current, I, gives us apparent power, S, not the useful active power, P. We need a device that inherently accounts for the power factor cos, phi. That device is the electrodynamic wattmeter. 2. The working principle. The wattmeter's operation is based on the fundamental principle of the dynamometer. This principle states that a force exists between two current-carrying conductors. In the wattmeter, this force is used to create a deflecting torque that is proportional to the true power. 3. Construction overview. The electrodynamic wattmeter has three main components: two sets of coils, a moving system, and a control damping system. For the fixed coils, current coils, CC. The two fixed coils are connected in series with the load. They carry the load current, I_L. Since they carry the full current, they are made of thick wire with few turns and act like an ammeter. Their function is to produce a magnetic field proportional to the circuit current. 5. The moving coil, pressure coil, PC. The moving coil is connected across the supply, in parallel with the load, and carries a current proportional to the voltage, V. It is made of fine, many-turn wire and connected in series with a high non-inductive resistor to limit the current. It acts like a voltmeter. 6. How torque is produced. The current coils, CC, create a stationary magnetic field proportional to I. The pressure coil, PC, suspended within this field, carries a current proportional to V. The interaction between these two magnetic fields produces the deflecting torque, T_d. 7. The torque equation. Crucially, the instantaneous deflecting torque is proportional to the product of the two instantaneous currents and the cosine of the angle between them, the power factor angle/phi. The average deflecting torque is given by Td is proportional to V*I*cos, phi. Since P is equal to Vi cos, phi, for AC, the torque, and thus the meter deflection, is directly proportional to the true active power, P. 8. Control and damping systems. To bring the pointer to a defined rest position, a control torque, T_c, is provided by spring control. To stop the pointer from oscillating too much around the final reading, air friction damping is typically used. 9. Reading the scale. The wattmeter's pointer moves over a calibrated scale. Since the deflection is proportional to P, the scale reads directly in watts, W, or kilowatts, kW. 10. Connecting in the circuit. The CC is connected in series to carry the load current, and the PC is connected in parallel to monitor the supply voltage. The instrument measures the power consumed by the load, making it the most versatile and historically important power measuring device.